what you need to know before is that the derivative of f is f dash of f. So we have, that's the function. This is this first derivative. And the second derivative is the derivative of the first derivatives. So f dash of x is d on dx of f dash of x. So to find the second derivative, all we need to do is differentiate the first derivative. So we're asked to consider the following diagrams and match these diagrams to f dash of x and f double dash of x. So before doing that, rather than actually look at the diagrams and just trying to guess it out which one it is, it's helpful to just like do it by yourself first and then see which one matches so that you're not prone to some biases. So in this case, I'm just going to try and work out the second derivative from first principles. Now we know that we know that the first derivative is the tangent to the function. So we know here and here the tangent's going to be 0. So the first derivative is going to cross the x-axis here. These are the turning points and midpoint. Now we're going to think about how the slope is changing. So here, on this side of the graph, the slope is positive. So that means that the graph is somewhere here in the positive range. And if you've seen what this looks like, if this represents something of a 3x of an x cubed, which when you differentiate go to 3x squared. So actually the differentiation is a quadratic. It is a simple quadratic. Here in this graph, this range of the graph, it is decreasing. And it is also negative, as you can see compared to here. The tangent is negative. So the derivative is going to be in some sort of this area of the region. But then once it gets up to here, changes from negative to positive. So that means it's going to flip back up here in the positive region. So you can just reason through that it's going to look something like this. Then to find the second derivative, we find the derivative of the first derivative. So we know that it's going to cross the axis at this point because there's a minimum there. And in order to find out whether it's like this or like this, we know it's like that because when we differentiate this, it's just 6x. This is not the function. This is just probably some form of the function. So we know it's going to be. So we probably know it's going to be a straight line. But is it going to be like that or like that? So we can just. So what we have to do is we look at this graph. Here you can see it's going negative, and then on the other side it's positive. So that means the function should be in the negative region first, and then in the positive region. So it'll look something like this. And then we check our graphs and see if any of them match, and if they do, that means we did correct. So this is our first derivative. And then, let's see. Here, this is our second derivative. Why isn't it this one? Well, because the minimum doesn't occur at the origin. The minimum occurs over here. And it's not that, because it doesn't look, because if it was that, it would look like this, which it doesn't look like the other one. And yeah, so here I, and here this is IV. Oh, wait, they want us to draw in a little box. IV, and that's the answer.